All right, welcome everybody. My name is Kathryne or Katie Chiqui. I am a math teacher and instructional coach with Minneapolis Adult Education. I've been there as a teacher for over 10 years. I worked there as like our learner support staff prior to that. I'm a member of our Minnesota Adult Numeracy team, and I'm really excited about that work. And I actually have been a member of the Journey program through Math is Figureoutable and their Leader Journey program for the past 2 years. And so I've gotten to work with Pam and Kim a lot and develop my own numeracy in this area. And so I'm just really excited to share stuff with you guys today. I'm also an avid soccer fan. So just a little tidbit about me. So my goal for today is that I want you guys to have some more opportunities to develop your own numeracy. I want you to be able to experience how to sequence problem strings within lessons. So you'll get at least one opportunity to experience like a sequence in today, as well as learn about how learn other ways that you can also sequence it. So you'll get to experience one way today, and then we'll talk about some others. I want to give you time to reflect on all the learning you kind of have done today and determine like next steps. Like, how would you envision yourself being able to use problem strings in your own classroom? And then finally, kind of wrapping up with access to free materials that you can use to continue developing your numeracy if you are interested. And as we all know, that as adult educators, right, we're on a tight budget. And then also, if you are willing to pay or get your program to pay for things, what are some other paid resources that you can use? So as Pam has already talked to you guys about today, problem strings are, it's a routine that you can use with students where you have a group of problems that are intentionally sequenced together to develop and build relationships between numbers. And so it is very different than just putting problems up on the board. And so as part of this routine, I usually have my own students. I tell them I'm wanting you to mentally solve the problem. And then when you are ready, I want you to type your answer in the chat, but I want you to wait to send it. We're going to do a waterfall. I want you to also be prepared to share and answer how you solved it. And be prepared to listen to other people's thinking. And finally, be prepared to answer questions that I might ask. You like restate another participant's thinking or what you understood about their thinking. And that's to, again, give them an opportunity to solidify that understanding of other ways of thinking. All right. So I want you guys to type these answers into the chat box, please. First thing is, what is your favorite snack? When you're thinking about, you get to go out to the store and buy anything, what is your favorite snack to eat or munch on? Ooh, seaweed sheets, okay. Chocolate. Chips and dip, okay. Goldfish. Authentic tacos. I love that that's like your snack rather than like a full meal. Nuts, popcorn, roasted chestnuts, milk duds, okay. All right. Now, does your snack change if you were, let's say, going on like a road trip? What is your favorite snack for on the go now? Very specifically, not necessarily you're sitting at a desk eating anything, but like maybe you're in the car, maybe you're something where you're on the go. Love it. Doesn't change. Okay, Sarah. Gardettos. All right. Twizzlers. Trail mix. More chips. Same. Chocolate. Oh, chips. Chocolate caramel. Okay. Still goldfish. Sunflower seeds. All right. Well, Bruce, my kids are very much like you. Their favorite thing to eat on a road trip are sunflower seeds. So we are going to talk about if we had a bag of sunflower seeds, okay? And I want you to imagine that if you had one bag, that one bag has 122 seeds in it, okay? So one bag has 122 seeds, okay? How many seeds would 10 bags have? Type the answer in the chat, but wait to send it. Wait to send it. All right, hit enter. All right, looks like everybody's kind of saying 1,220. Okay, nice. Heather, would you be able to unmute and tell me like how you got that?
Nope, still not doing it.
I hear you now.
Okay. Yeah, I did it the old-fashioned way because I still don't understand problem strings.
Okay. Thank you for your honesty. I appreciate that.
Yep.
Okay, hold on, guys. I'm realizing that I cannot scroll through my chat and annotate on the board at the same time. Cool. Donna, would you be able to unmute and tell me how you thought about your answer?
Hello. Yeah, I thought about like timesing by 10.
Okay.
So, and then doing that to both pieces of it. So the 1 by 10 and then the 122 by 10. And then it was lovely because it has a 0.
Nice. So what I heard you say is that because you knew that if I have 10 more bags, 10 times as many bags, I'm gonna have 10 times as many seeds. Okay. Nice. All right. Now, what if I actually decided I don't want 10 bags. I only want 9 bags. I only want 9 bags. Type your answer in your chat. Do not hit send yet. All right, hit send. Ooh, Jeff typed in his thinking. And because I only see one person with an actual answer there, it means I did not give you guys enough time. Okay, I see you guys are thinking. All right, I'm having a little technical glitch where I open up the participant frame, and because I'm on annotate mode, I cannot get it to close. Oh, never mind, I was able to do it. So sorry. Thank you for your patience. Zoom is not my preferred platform, so I greatly appreciate your patience. All right. I'm trying to remember. Just looking through the chat here to see what you guys have written. Hey, Jeff, can I have you unmute and tell me, how did you think about this? How did you figure out 9?
You said Jeff, right?
Yeah.
Okay. Well, I jumped right in and kind of as a student, I just thought it's going to be one less bag, and one bag is 122, and what we have right now is 1,220, and I just subtracted 122 from that.
All right, so when you said one less bag, do you mean from the 10 bags that we had, we just needed one less?
Yes.
All
One
right,
less
so,
bag on our table.
all right. Oops. Hold on. Oh, come on. And then because of that, you said you have the 1,220 in the 10 bags, 1,220 seeds, and you're taking the 122 seeds away because you took away one bag.
Yep.
All right. And I'm sorry, you guys, navigating, going back and forth between the little arrow and being able to write is different than my platform for teaching. So it's throwing me for a loop. All right, it looks like you guys have 1,098 is your answer. So when we subtract 1,220, hey, did anybody start with subtracting 100? Did anybody start with subtracting 100? Okay. Sarah says yes. And what you guys, if we just subtract 100 from 1,220, what do we get? Right? You get 1,120. Nice. Okay. And then what haven't I subtracted yet? What do I have left to subtract still? I've subtracted 100. Oh, Luell says, okay, subtract another 20. So if I'm at 1,120 and I subtract 20, would I be at 1,100? And then I'd have to subtract another 2 to be able to subtract 122. Yeah, Carly. So 1,100, if I'm taking 2 away from 1,100, what would I have? Would I get the 1,098? All right. Okay. So Pam actually went over this strategy a lot with you guys today, with working with multiplicative thinking, with working with addition and subtraction. And so I'm hoping that this is again, like just going to help like you experience this a little bit. But I want to be able to make sure that I am challenging you guys just a little bit more. And honestly, you guys, this is like the one bag of like 122 seeds. If we think about this, like this is the kind of bag that you walk into like maybe the convenience store, like the gas station on your road trip, and you're going to get that like that little bag that you can get. My kids love sunflower seeds. Like they really love them. And so when we go on a road trip, we got to go to like to Costco or Sam's Club, like one of those big bag stores. And so when we get those kind of bags have a lot more seeds in them. Like a lot more. The bag that we typically get has 2,300 seeds in it. Okay, so 2,300 seeds. So if one of those Costco size bags have 2,300 seeds in them, how much would 10 bags have? How much would 10 bags have? All right, you guys can type those in the chat. All right, you see 23,000 seeds. So one bag would have 2,300 seeds, 10 bags, which is 10 times as many, would have 23,000. All right. Now, what if what if I said we don't actually want 10 bags, we only need 9 bags. There's only 9 people going on this trip, and so each of them get their own little bag for the entire road trip back. Like recently we went down to Texas last year, so like road trip down to Texas and back, each person gets their own bag. Then we're not fighting over things. So if I only want 9 bags, there's only 9 people going, how many seeds am I going to have for my road trip? Type your answer in the chat, but wait to send it. Wait to send it. Okay, why don't you hit send in that chat? All right, so I'm seeing 20,700 there. I'm seeing 20,700. Chris, can you tell me how you figured that out? Would you unmute and tell us how you figured that out?
So I used a similar strategy to what we used in the first set that you had us do. We know what 10 is, and we know what 1 is, and 9 is 1 less than 10. So I just took the number that's in 10 bags and subtracted the number that's in 1 bag.
Hmm. And
the Zoom chat told me the answer when I hit the equals sign. I didn't know it could do that. Kind of
Does
mad
it
about it.
really? That's kind of crazy. Did anybody else know that?
How do you teach math when it tells the answer if you're online? That's wild.
Yeah. I'm glad Zoom is not my platform then, because mine doesn't do that. Okay. All right, so we could do this as we're thinking about having 23,000. Oh, sorry, guys. And if we're subtracting 2,300, we could think about that as maybe starting off as subtracting 2,000. And I know my number lines are not going to look as pretty as Pam's. And if I subtract 2,000 from my 23,000, what would I end up with? I have 23,000, I'm subtracting 2,000, 21,000. And if I started with subtracting 2,000, how much more do I have left to subtract? All right, 300 more. So I have to subtract 300 more from my number. So 21,000, and I'm subtracting 300 from it. Do I end up with 20,700? All right. Now, when we went down to Texas last year, we went for a dance competition. And so because my kids love sunflower seeds so much, they wanted to bring bags for all of the dancers, which means that we had to buy them in bulk from Costco. So they only sell them by boxes of 100 though. So if we had bought 100 bags, which was 1 box, how many seeds did we buy last year? How many seeds did we buy last year? Type your answer in the chat, but wait to send it. All right, send that answer. All right. 230,000. So you guys, isn't that just like, oh, come on. Sorry. Isn't that just 10 like times more, right? So if I have 10 bags and I'm buying 100, that's 10 times as many bags. So I can take that many seeds and I can multiply it by 10 and I get 10 times as many. Nice. Well, yeah, I see that in the chat. Perfect. All right. So my kids being the sneaky children that they are, of course, instead of being able to get the box of 100 bags, by the time we left Costco and on the way home, they had already opened one of the bags. So I no longer had the 100 bags to be able to bring down to Texas. I only had 99. So with my 99 bags, how many seeds now do I have to bring down to Texas? All right, send your answers in the chat. All right, it looks like you guys are saying 200,027. 700. It's hard to read numbers, you guys, when they keep coming in. Come on. All right. So, Robert, would you be able to unmute and tell me how did you figure that out?
Hi, I would say that what I did was incorrectly. And I took the minus 2000 and then I did the minus 300, but goofed up. So my first answer is 300 off. So,
Hey, can I tell you something? So when I first started doing this, the over strategy was the one that I kept messing up. I would add back on instead of remembering to take things back off.
yeah.
So, been there, done that. You are not alone in that process.
Oh,
Okay?
good.
Very
Thanks.
normal.
Thanks, Katie.
Yeah. So it sounds like what you had done though was you were talking about the fact that you used the 100 bags and then you used the one bag. And so you said, I don't need the 100 bag. I don't need 100 bags anymore. I only need 99. So you took one of the what you knew about how many seeds were in one bag to get the 99 bags.
And I broke it down into two pieces. First time minus 2000, second time minus 300 and goofed, but it's better now.
All right. Great question, Janice. So when we talk about mental math, it doesn't mean that they have to carry all the load in their head. When they are writing things down, though, we want them to write down things so that they at points to help track their thinking. So that's why like we do things like this on the board to be able to figure that out. So for example, Robert talked a lot about like he started at the 230,000 and he knew he wanted to subtract to 2,300, but like doing that in one move was too hard. And so, which I totally get, I break it down as well. So he said, I'm going to subtract the 2,000 first. And to get the 230,000, I can think about 230,000 minus 2,000. Oh, that's just 2,000 less. So if I have 230,000, 2,000 less would be 228,000. And then I have to stop and think about, okay, so what was I supposed to subtract? I was supposed to subtract the 2,300. I only subtracted 2,000. So I have the 300 more I have to subtract. So now I can think about my number 2,200, I'm getting tongue-tied. 228,000 and take 300 away from that, which we can, again, show on this number line. And 300 less than 228,000 would leave me with my 227,700. Yep, that's another great way. All right. So I want you guys to just pause and think about this, that you guys just figured out this problem. And you did it without using the traditional algorithm. Okay. And so what you did was you thought and reasoned through this and were able to use the over strategy, and you might have had some hiccups along the way, or you might still be struggling with this and you might need some more exposure to this kind of strategy. And that's normal. Some of my students get it on the first problem string, but most of my students need to see multiple problem strings to be able to really like dig into an idea, dig into a strategy. Yeah, Carly, that's a big math problem. All right. Any questions about this problem string? Okay. So I have some reflection questions for you guys. Well, that's a great question, Chris, and I'm gonna have you hold on to that until after the next activity. Is that okay? All right. Gail, would you be able to send out the first reflection question, please? So the first question I want you to think about, and I kept this up here rather than putting out my slides or changing the slide, because I wanted you to be able to see what we did. So how can we use a friendly number like 10 or 100 to help us solve problems like these? You guys can type your answers in the chat. How can we use a friendly number to help us solve problems like these? All right, you guys have some great ideas. So I'm seeing things like we can use numbers that like learners can understand or that they're more familiar with to help them get things that they're not familiar with or that are more challenging. Same idea there, it looks like with what Luella wrote, and then using maybe, so smaller numbers can help us with mental load for bigger numbers. So are we talking about like the fact that we're looking at 10 bags first, and then we can think about 100 bags? All right. So the over strategy helps us, we can think about multiplying by 10 or multiplying by 100, or somebody else put multiplying by 1,000. And then we can like remove a group or groups potentially. So for each of these, for like in order to figure out how many seeds were in 9 bags, rather than just going straight to the 9, we figured out 10, and then we were able to just remove one of those bags. I have a side question right now because Zoom isn't my platform, you guys. Can you see my cursor moving on my slides? Okay, thank you. Otherwise, what I'm saying would make no sense. Appreciate you guys. All right, so with that idea, we can look at a number that's friendly, and this goes for other numbers as well, but I was using numbers like 10 and 100, but then we can remove groups, and the context helps. Removing a bag, right? Instead of having 10 bags, I'm going to take a bag away. That means I'm going to take that number of seeds away. And to kind of follow up with what we're talking about, when do you guys think that the over strategy would be useful? And Gail, can you put that into the chat for me, please? When do you think using this over strategy would be useful? When you're closer to a higher, friendlier number. For estimating, to do mental math with higher numbers. To evaluate if an answer is reasonable. Yeah. These are great. When do you guys think, like, for what kind of numbers do you guys think an over strategy might not be like the strategy you want to go to? Like, when would it not be super helpful? All right. So I love seeing what you guys are typing in the chat. So maybe like people are saying, well, maybe when it's a fraction. And I'm going to tell you, actually, I'm still building my numeracy with fractions and using these strategies, but I can tell you that, like, for me personally, using this for like decimals and for fractions is actually, in certain cases, super useful. If you got a decimal, like, for example, hold on, I got to turn my marker back on. If I got a decimal that was like, over strategy is not going to be super helpful with that. Not super helpful. But if you have a decimal that's like, I can think about this as 3, and then the over strategy can be helpful. Same thing with fractions. If the fraction is close to a whole, that can be super helpful to be able to use the over strategy. Now, if you are just starting this, seeing those relationships though is super challenging. So if we're talking about like whole numbers though, which is what we've been working with in this problem string, so I'm just trying to keep up with you guys in the chat. And yeah, using like 55, like you're really far away from one or the other. So then the over strategy isn't quite as useful then. So when a number is really close to like one of your friendly numbers or a nice number is like what my students call it. So like number like 10 or 100 or something like near 20, or if you get those kind of numbers like 21, you could use, it wouldn't be the over strategy in the sense of you're not going over, but you can still use 20 and then you can add on, you can tack on another one. So this problem string, this strategy is one that I actually didn't use very often prior to doing the work with Pam. but I am super, I'm a much better user of this strategy now than I was when I first started 2 years ago. All right. I'm getting behind on time. So nope, that's not what I want to do. Hold on. Sorry, guys. Give me a second. There we go. All right. Come on. All right. Thank you. That makes me feel better. Appreciate you, Janice. All right, so what we're gonna do now is what I like to call a multiplication division workout. Okay. This one happens to be about chewing gum, or the brand Chew Gum, and their packs. Each pack contains 22 sticks. So in small groups, you guys are going to use ratio tables and try to figure out how many sticks there are in each of the different numbers of packs. I invite you and your group members to think and reason about these problems rather than using the algorithm. So when you are put into your breakout rooms, okay, I would recommend that you have at least one person sharing their screen and at least one person recording, okay? If everyone is able to open the Padlet on their own and you want everybody to be able to jump in and do it, by all means, go for it. However, if you have people in your group that might not be as comfortable on this platform or navigating Padlets, then I would encourage those that do feel more comfortable to help lead. Once you are in, once you are in your room, you are going to see, this is going to be the first page of the Padlet, and that's like this one up here. First, you're going to find your group's page by clicking on the group number that you were assigned in your Zoom room, your breakout room, and that will show up right here on the page. Okay. And the second thing you're going to do is talk about the problems as a group. I want you to feel free to use any of the annotation tools that will be here on the side, and I encourage you to make your thinking visible. If your group happens to finish before time is up, please feel free to start thinking about the discussion questions that we're going to do when you come back from this activity. Are there any questions about what you're supposed to be doing when you get put into your breakout rooms? Okay, you will have 16 minutes to work plus a 2-minute reminder. Please click on the link for the Padlet. It's in the chat box right now. And then Gail, you're up to break us into, or put us into rooms.
Okay, I'm going to open them right now.
Thank you.
Mhm.
All right, welcome back, everybody. I want you guys to type your answers into the chat. I'm going to do a little bit about reflecting right now. And I want to know, how did the problem string help prepare you to think about the problems that you just did? So think back to the problem string that we did at the beginning of the session. How did that help prepare you for the workout that you guys just did? Type your answers in the chat, please. Sarah, can you unmute and can you share a little bit more?
Yeah, sure. I think if I'd seen like the problem like 999 packs or 999 sticks and trying to go, oh my gosh, okay, I have to start doing long multiplication. And instead starting, like you said, with a friendly number and working from there, not only makes it so easy, but so intuitive.
Thank you. I'm just looking through the chat, what you guys said. Yep. Okay. Thank you, Adam. Yep, Donna. All right. Well, I agree. Thank you, Robert. All right, Heather. All right. Good, Chris. Thank you, Marissa. All right. So a lot of you kind of just said that it helped you by doing the problem string first. You guys were able to use like that pattern that you guys saw, the knowing that you can go for just a slightly bigger number and work with numbers that might not be, that are a little bit more unruly, and make it more manageable. You guys also talked about how we started lower and it kind of the numbers amped up in size, but it didn't feel overwhelming because of what we've done before. So the same thing is true for your students. And I know one of the things that teachers were asking about in the main session from Pam was, how do I get my students to buy into this if they're just focused on the test? And this very workout was actually one of the turning points from one of my students who was all about algorithms all the time. And when we did this problem and we got to the, I think this one is the one that has 1,000 times or 1,000 packs of gum. What if I have 999 packs of gum? And trying to do that with the regular algorithm was so much more work. He was like, it was just so much easier to think about 1,000 packs and then just take away a pack. And so like that, this very workout was one of the ways that I actually got a student that was very algorithmic based in thinking to buy into this, to buy into to thinking and reasoning. Luella, I see your hands up.
Yeah, I was also thinking, because on the GED test, when a student sees this, they want to like automatically just fill in the table until they get to that magic number. And because it's time, they waste so much time just filling in the table. Where I feel like this really just kind of cuts through that and helps them with time,
Yeah. All right, next question. How did the ratio table compare to other ways to solve the problem? So what I mean by this is, how did that ratio table help you kind of document your thinking compared to other ways that you might use? You guys can type your answers in the chat. I love what you guys are saying. So I'm seeing that it helps you organize your ideas. It helps you be able to like keep track of them, find the information later so you can reference it. Helps you kind of digest a little more complex problems. Loving all that. So one of you guys asked at one point in time, am I supposed to be able to do all of this in my head? And the answer is no, but like a ratio table is one of the ways, and a number line is another model that you can use to help you like document some of your thinking in an organized way so that you can go back and you can use it and you can track your thinking. And so ratio tables are a great model that you can use with students. And as it's already mentioned, you have in and out tables, you have like, they're that idea. And it's a great model to help students track their thinking. All right, final question. How did the context help you think and reason through the problem? How did the context help you think and reason through this problem? So remember that this was with the worksheet, you were working with packs of gum. How many sticks are in a certain number of packs? So Janice says it helps her have a visual in her head. Carly says it makes it real. All right. Something that most people can relate to. Helps keep track of number changes with which number affects which. Ooh, especially when two numbers are changing at the same time. So Luella, what you just talked about is one of the most challenging things that students, when they start using the ratio table, have, is that they oftentimes, if you're subtracting a pack of gum, they want to subtract just one stick from there too. And so they think because they're subtracting one from one side, they want to subtract one from the other. And so the context I have found really helps students understand that if I'm subtracting one pack of gum, how many sticks are in a pack? In this case, it was 22. So they have to know to then subtract 22 sticks, because in a real life situation, if I were to take away an entire pack of gum, I'm not just taking away a stick of gum, I'm taking away the entire 22 sticks. Interesting. So I appreciate both Adam and Jeff saying that, Adam said he didn't use it at all, so he's neutral on it. Jeff says it caused actual distraction. Jeff, can you tell me more about why it caused distraction?
I think maybe because I focused on thinking of packs of gum from, I suppose, when I used to buy packs of gum, and I don't remember any having 22. I remember like Juicy Fruit having 5, and there were probably larger ones that had friendly numbers like 10 or 20 sticks. But then I was like, oh, I like the context, but I'm just going to stick with the numbers for now.
Okay, fair enough. I really appreciate that. Do you know that there's actually almost every single brand has a different number of sticks? So I actually Googled and I was trying to find 22 because I wanted to put a picture on it so you guys could have a picture of it, because I love pictures and visuals. And Bubble Yum actually sells theirs, their packs with like the little itty bitty sticks. They're not like the long ones, but they're like little kind of rectangles. They sell them in packs of 22. So I was super excited. I was going to use that as a picture on one of the slides, but because it's copyrighted and it's not open sourced, we can't. So I had to stick to the generic that they used in the actual task itself, which was, I think, Yum or something. I can't remember now. But yeah, Juicy Fruit said as 5. If you think of like I'm trying to think the little ones that come in the plastic boxes that actually aren't even sticks, they're kind of like little rectangles of gum, right? They all come in different amounts. And so that's the fun thing, depending on what number like you end up picking, and there are intentional to why I picked 22 or why there's certain numbers that were picked. But those numbers, and that gets to being able to write your own problem strings, those numbers are important because the more you can like put them in context for students and make something real, the more that they can actually work through the logic of, well, I have to proportionally kind of change this, because ratio tables and the way that you guys were thinking about things was actual proportional changes. If I'm taking out one pack of gum, then that means I have to take away this many sticks of gum. One pack doesn't equal one stick. And so it helps develop that proportional reasoning prior to actually doing proportional reasoning problems. All right. I want to make sure that we get through everything. So the next thing I want to talk to you guys about is kind of like probably why you actually came to this session. One of my big questions when I first started working with problem strings was trying to figure out like where to put them in lessons. And at first I was just trying to develop my own numeracy. And so I would go in and I would actually just do a problem string kind of anywhere in a lesson that it fit. And sometimes it wasn't even related to what we're doing, because I was trying to build numeracy in where I saw holes in students' ability to do like leveled tasks to whatever class they were in, because I teach in leveled classes. When they weren't able to do tasks because they were missing a piece of numeracy, I would try to throw in problem strings to build that numeracy up. And so one of the things that as I got better at doing problem strings, I really thought hard about how can I tie these into actual lessons and tasks that we are doing. And so as I developed my repertoire, you could say, and my access to various problem strings, I was able to start sequencing them more intentionally. And so I'm not as big of a big picture person, but I know that there are lots of people out there who really need that big picture to be able to kind of then focus in on the smaller things. And so the sequencing piece, there are three main ways that that I see and that I've learned problem strings work really effectively. The first is the kind of what we did today, and that was the preview. So problem strings can preview a strategy or a model or numbers that you want students to be able to access more readily for an actual activity. In fact, the way that I was actually going to use this task before was the last sequence that I'm going to talk about today. And instead I had a rich task I was going to have us just start. And I was going to preview the numbers in that task, which were fractions. And that I think it works with eighths and twelfths. And those aren't fractions that like you typically kind of like want to be moving between. And so doing a problem string where you got that exposure of how to think about eighths as they're related to twelfths can really help students get grounded and access those numbers so that when you're giving them the task, they're not caught up in the numbers. They're able to use the numbers to help problem and reason through the task itself. And so that preview piece can be really good use for problem strings. There are times when I actually use a problem string as my main lesson. It might be that I'm really wanting to build a strategy in students. I'm seeing that like the over strategy is something that students are getting stuck and they're trying to they're not able to not use an algorithm because they have nothing else to use. And so I might use the over strategy as a main lesson problem string, and I would do a longer problem string in that sense to give them lots of practice. And then be able to connect it with like a warm up or a exit ticket then afterwards. So they can be used as a main lesson. Problem strings can vary in time from 10 minutes all the way up to 30 minutes, depending on how deep you're going. The lesson or the problem string that Pam did at the very, very beginning, where she then she did the main problem string and then she extended it into graphing and talking about, writing equations. What does a graph look like? How does it shift up? How does it shift? Like those are all things that you could start out with a problem string and then you may go into the graphing if you're doing the upper levels of math. And so that's a really great way that you can then use a problem string as kind of like your main chunk of your lesson. Yes, there is, Adam. And I'm going to get to that at the end. I'm going to show you guys some resources where you can find free problem strings. And then if you are keep wanting to dig and keep wanting to develop, you can then get more access through paying, whether it's for books or subscriptions. The last way, and this was the way that I had actually intended on doing the activity we did today, was I was going to give you this activity up front, and then I was going to wrap it up with a problem string at the very end. And what I mean by that is I might give you the activity that we did today to students, and then I wrap it up. And when I'm wrapping it up, I mean that I am talking about and reflecting on the learning. When do you use the over strategy? What kind of numbers is it going to be helpful with? What numbers wouldn't you use it with? Great. And then I might create an anchor chart that I can put up in my classroom. An anchor chart is usually like a poster that I could put up in my classroom then, and students then can reference it. So as they're working through problems, I might say, hey, have you tried any of the strategies that are up on the wall if they're stuck? And that way then we are kind of finalizing and cinching that understanding of a certain strategy or of a model that we've been using. And that way they have something that they can reference back when we're continuing to do math in class. So those are the three primary ways that I've seen lesson or problem strings used in lessons. Are there any questions about the sequencing before we move on?
Hey, Katie. I
Yeah.
was wondering if this is something that you can kind of do in reverse. Like, for example, if you're doing division and you're given the bigger numbers, like starting with 1 makes sense and working up. But what if you get like a problem that's a bigger number and you kind of want to work backwards? Is that accessible?
Yes, it is. And actually, I am working through the division workshop right now with her. And actually, let me do this. Give me a second. I'm gonna see if I can toggle between something. I don't know how big I can make this though. That is not making it bigger. So I'm sorry I can't make this bigger, and I should have put this on a slide, but I didn't. This last problem here, where it's asking you, Juan wants 446 of gum. Use the following ratio table to help you determine how many packs he needs. So we were always starting with packs and working towards sticks. When you're talking about how many sticks I have and how many packs I need, you are actually doing division. You are doing the problem 446 divided by 22. So if any groups got to that number 4, you were actually using the ratio table to do long division, or to do division, not long division. Did that answer your question?
Yeah, I guess so. You're still given kind of like a 1 equals 22. I guess I'm thinking maybe if you were given a problem like if money, 440 sticks costs this much, how much is 1 pack cost?
Mm-hmm. So this is where it gets into, it depends on if it's partitive or quotative as to whether or not a ratio table makes more sense or not as much sense. And then
Yeah.
you can get into other thinking. And like I said, I'm still learning about, I'm still developing my numeracy in that area. So one of them works really well with the ratio table, and I can't remember which one. I'm sorry, I don't have more information for you.
No, that's okay. Division just feels like particularly people are inclined to do an algorithm because otherwise it's just like, hard to access. But this seems like a possibility.
So like one of the things that I talk about with students, because I've tried to build division sense, and hold on, I'm gonna go back to my blank screen to, if you're thinking about like the problem 440 divided by 22, right? Like that was the problem that you're essentially given. When you're thinking about this, you can think about like, okay, well, instead of maybe thinking about like 440, I could also think about the fact of, okay, how many 40 or how many 22s are there in 44? Well, there's 2 of them. Okay. So if I know that there's 2 of them in there, I can think about, okay, well then what would I have to do to get to 440? I mean, 440, yeah. And that's 10 times as much, right? So you're thinking about doubling something in 10 times as much. So I believe the answer to this is actually 20. So you can get students to start to think about these relationships that they do see in numbers, or you can break this number down and you could think about instead of scaling this number up, you can think of breaking this number down into smaller chunks.
40 and 4.
Yeah, like you could do 440, right? Like, so you could do something like that, or 44, and like there's, you're decomposing the number, and so you're doing not partial products, but it's partial sums, I think it is, but it's division. I can't think of the actual name, but this is the, that's not the right book. I have it, it's the ebook that they have that on there, and they show like how that looks like, and that's also something that I'm still working on. But promptings can help you develop those skills because you're seeing the things in high dose patterns. And so you're developing your own numeracy, and then you're helping your students develop that. And they don't have to be stuck in this long division process where nobody can remember the steps because you're adding, you're subtracting, you're multiplying, you're dividing, you're doing all of the things in one algorithm. So, all right, I'm
Yeah.
gonna
Thank
back
you.
on track.
Thanks.
Let me see here. How do I get rid of the writing? Come on. It was working so nicely. All right. So last thing I want you guys to be thinking about is, with all the learning that you guys have done today, okay? What is your, like, just think about one question And I want you to like type in the chat, what is your one big takeaway from today? Or how do you plan on using problem strings in your classroom? Or if you're at what, if any, support or resources do you still need to be successful? I want you to take some time and type that into the chat. All right, so I see a lot of you guys are talking about wanting more resources. So I'm going to jump ahead. And I'm more than willing to stick around and chat with anybody if you have more questions. But I'm hoping these resources will help get to some of what you guys are wanting. So first of all, I want to give credit where credit is due. The prom string that we did today came directly from her 4th grade prom string book. I actually own that book, mainly because I work with levels A and B. And so a little bit of C. And so I can make a lot of use out of that book. I also use this other book, which is more kind of middle school, I would say, based, but it can help with the gaps in students in higher levels with their numeracy. It can help fill in those gaps really well. And it also has things like fractions and decimals and percents, which are things that we know that students at all levels really just need more practice with. And so both of these books are ones you have to purchase. So unfortunately, these are not from the free section, but I would highly, highly recommend the one on the right for any level, honestly. It is jam-packed full of also some of the things that she talked about that she posts on Facebook. Some of those and extended problems are in that book as well. So it's not just full of problem strings, it's full of building like equivalencies and the understanding that the equal sign doesn't just mean solve. It means how is this value equal to this value? It has lots of different additional kind of routines that you can build in. So when talking about resources, the things that if you are interested in learning more about prom strings in particular, if you go through and you have access to my slides, the prom string hub, there is a free prom string hub for her. It does have, and I think she does them categorizes them by addition, subtraction, multiplication, division, but I could be wrong because they just, a year ago, they reorganized everything. And so I'm trying to remember whether or not that change was before or after a year ago. So, and the episode that I have listed there, episode 71 is all about problem strings. And so if you're wanting to learn more about how to implement problem strings, there are many podcasts that she have episodes about problem strings, but that one is kind of like, this episode is only about problem strings and how to get started with them. So I highly recommend listening to that. And then their website is right here as well, Math is Figure Outable. And they have a ton of free resources on there. Okay, not everything is paid. So again, I would highly recommend those to kind of get started with just problem strings. if you're wanting to learn more and you are really like, okay, give me more, they have a podcast that I think they just hit more than 200 episodes on. And you can go onto their website and for their podcast and you can search up like keywords. They have a great series also on about how to sequence tasks. And how much time, Adam, you were asking about how much time do I dedicate to problem strings, how much time do I dedicate to other activities, or how much time do I dedicate to algorithm? Pam would tell you 0 time to the algorithm. She says, do not do it. And if you are, for example, in K-12, where you're mandated by your state standard to teach it, then she says, teach it on the last day of school. So I can tell you what her response would be. I know that when I first started doing it, I still taught the algorithm until I said, okay, this year I'm not going to teach it at all. And that doesn't mean I tell students in class that they can't use it. I encourage them to try to think and reason, and it takes some time. But you got to find just those small little pieces to buy in. And even if they can't get to the final answer, can they start it? Can they start by saying, oh, okay, well, I know that I need one. I know in order to figure out 9 packs, I'm going to have 10 packs and I can subtract 1 pack, but then they get stuck. Cool. Have them share that much and then ask another student in class to take over. And does anybody know how to finish what Heather started over there or what Katie started over there? Like you can have students do that. Math Strat Chat is what she talked about. It's on Facebook. It's, I think, also just on the web, but it's housed in Facebook. Every week you can jump on there and you can read people's strategies because I type them in there. You can ask them questions. If you don't understand what they're talking about, you could say, I can't follow your thinking. Can you please tell me more? And they will go on there and they'll explain more. That's a great way that I've been developing my own numeracy more.
Crunchers, and they're trying to figure out how this can be done. Give us some guidance. What the president said logically was, okay.
Heather, you are unmuted.
Oh, I'm so sorry.
Okay. There's the instructional routine hub that I talked about for problem strings. And then they have other instructional routines in there as well, not just problem strings. And then paid resources, they have workshops that if you're wanting to do a deep dive, let's say you teach GED level math and you're wanting to learn how to do problem strings at the high school level. Again, everything's predominantly set through K-12, but everything that she has is not set up for kids in the sense of she doesn't have like cutesy little drawings on anything. It's all very much, here's the math, here's the reasoning I want you to develop. I know she did default to saying kids a lot. And so that was something so like know that the books are going to be organized because that is the largest population for teachers out there, right? Is to be able to cater to them. But she's learning that there are more and more adult educators out there that are wanting to learn more. And so she's starting to make sure that she's including us in how she's developing stuff. She has lots of different books. She's actually working on books right now. Journey is a group that you can become a part of where you have access to a workshop and then it will save your access to the workshop. Otherwise, when you do a workshop, you get it for, I think it's like 8 weeks worth of a workshop. And I think she gives you 12 weeks to do it. And then once those 12 weeks are up, like the material is taken away. And you are allowed to download things and keep them on your own computer, but like the entire workshop itself, all the videos and stuff are then back in the course that you no longer have access to. And so Journey is a way that you can keep adding that. I'm a part of Journey Leader, which is then for people who are working on building leadership within, making shifts within larger structures of education. And as a leader, I get access to every workshop and all the tools, which is actually why I started the leadership workshop because I wanted to learn it all. That is a lot of information, a little bit of time. I know that she previewed a lot of these things, which is why I didn't click on them to show them to you. I have 1 more minute left. Is there a question that I have not answered yet that you would like me to either A, ask Pam about because I do have access to Pam and Kim because I'm part of their leadership program, or B, is there something that you want to get my take on?
Katie, I would love your take on my question in the chat, which is basically time what's your recommendation for a time in class spent on algorithms versus problem strings methodology or instructional practice? And
So
what's the ratio, or what would be a healthy ratio, or should the goal be eliminating the ratio like Pam suggested?
So I can tell you that when I've tried to use the algorithm, like when I first started working with this, I was like, I started with doing the algorithm, and then as I was building my own numeracy, because I didn't know how to do anything else really, I was doing problem strings, I was doing different activities, but I wasn't seeing that it was making a large impact on students really understanding, because they then wanted to still do the algorithm because that's what they were modeled and that's all that they've really usually been shown, right? Our education system, I can speak for the United States, is very much here are the steps, mimic me, do what I do. But then that means a lot of times when students see problems that don't look like the ones we've done in class, they get stuck. Or if they can't remember the steps, they are stuck and they have nowhere to go. So based off of the 2 years of training I've already done with her, I would say as much as possible, cut out as much time on algorithms as you possibly can. So for the last 2 years, or I mean, last school year and then all of this school year, I have not modeled algorithms on the board in class once, not once. Now, I don't tell my students they can't use it or do it, but I don't model it for them. And I don't spend any class time addressing it. So if a student said, oh, I did it this way, I'm like, okay, great, that's awesome. And then I'll again, I will redirect to do whatever strategy I'm trying to pull up on the board. Hey, if nobody happened to use the overstrat or used, times 10, could we? What would you get? And it invites them to start doing that thinking. It is big shifts, and I work with a very, very small population. I work with the students that typically are not progressing in any of our other classes. And so I work with the students that have pretty much last year all the students I worked with, only one was not on an IEP from the past, or did not have significant emotional trauma or other things like that, as we know many of our students do. But all of them made significant progress in their ability to think and reason, and their confidence and their drive in being able to change from I'm not a math person to, oh, I can do math and I already know a lot. So, and I'm sorry, I just looked at the time, it's 2:18. Thank you, everybody. Again, I can stay on if you still want to chat, but I want to make sure that everybody is free to leave. I appreciate all of you guys.